can an elephant swim? If there was a big enough pool for the elephant. And a reason that a lot of people might say, well, probably not, is because an elephant is so heavy. They do have a lot of weight. But let's see if that means it's impossible for them to swim. In fact, it's not. As you can see in this picture here, this is an elephant swimming. In fact, the picture was taken from underneath the elephant. I wouldn't want to have been the photographer hoping the elephant doesn't put its foot down. But elephants indeed can swim. And you might wonder, well, how? They're just so heavy. It's not an unreasonable question. Well, let's look at a person. And let's say that person is 50 kilograms. I'm just making up a number. That's not unreasonable. If we found that person's volume, we would find that it's almost exactly 50 liters. So if we took the 50 kilograms divided by the 50 liters, we'd get 1 kilogram per liter, which is almost exactly the density of water. That's why we can float in water, because our density is just about the same, maybe just slightly more because of the bones. It depends on how much air we have in our lungs, but our density is really, really close to that of water. You say, well, what about that elephant? And I don't know what the elephant's mass is. Let's just pretend it's 1,000 kilograms. Well, yeah, the elephant is a lot heavier. It has a lot more mass. But what you would find is it also has a lot more volume. And its volume would be about 1,000 liters. So 1,000 kilograms divided by 1,000 liters would be 1,000 kilograms per 1 liter. The elephant's density and our density is about the same. We're both mammals. We both have blood and skin and muscle and organs and all that. It's kind of surprising. Yes, the elephant's heavier, but because there's a bigger volume, the density isn't more. Now, density is a physical property, and supposedly it comes to us from Archimedes, that he was the one who discovered this way back, a few hundred years BC. And Archimedes, the story was that he was trying to find the volume of a crown because he wanted to find the density. They might say, why a crown? The king bought this crown and thought he had been cheated. The king thought that the goldsmith hadn't really put enough gold into the crown as the king was paying for. And Archimedes wasn't sure what to do because the crown is in unusual shape. So what he did was he went to, they had, public baths back in those days. And he noticed when he got in the tub that the water level rose. Well, our bodies are irregular shapes. We're not a perfect cylinder or a perfect rectangle or anything like that. So then he knew he could take the crown, put it in water, and then automatically find what the volume is. And I believe the crown was not fully gold, so the goldsmith got in some trouble. So density is mass per unit volume, or mass over volume. Now, in chemistry, we're going to use grams. In physics, we would use kilograms, but in chemistry, we tend to work with smaller objects and smaller things, so we use grams. And for volume, we use milliliters or cubic centimeters. And a cubic centimeter of water is the same as a milliliter. So our density unit, for the most part, is going to be grams per milliliter. Occasionally, we'll do grams per cubic centimeter. In physics, you do kilograms per cubic meter. It's different. It's an intensive property. If you have a little piece of wood, a little piece of a 2x4 or something, or a little piece of a branch, and you put it in water, it'll float. If you have a big tree, big log of the same material, if the little branch floats, so does the big tree. Think about styrofoam. A little piece of styrofoam will float, like a little styrofoam packing peanut. They don't use them as much anymore, but they used to use them. And so would a styrofoam cooler. Now, don't throw them in a lake or anything that, we certainly don't want to pollute things with styrofoam, but they would both float. And I just want to remind you very quickly of the volume formulas. So for a rectangular object, it's length times width times height. So that would be anything that's very regular and rectangular. For a cylinder, it's pi r squared times the height. Remember, here's the radius. I'm sure you know these by now in your math career. If not, you need to memorize them. You need to know them. They're not that hard. So pi r squared, because pi r squared gets you the area of the top. And then we just multiply it by the height. If it's an irregular shape, like Archimedes was using for the crown, and we'll do this in lab, we're going to use water displacement. We'll do some cylinders and like a marble, so we'll be able to test that. And just remember the density of water is 1. So water is 1 gram per milliliter. So if we had a little plastic boat, like a little toy boat, maybe its density for the plastic is, let's say it's 0.85, and I'm just making up a number, grams per milliliter. But it has to be less than water in order for plastic to float. If we had a rock, well, the rock is going to sink. Its density might be, let's say it's 5 grams per milliliter. The numbers aren't really critical. What is critical, though, is we're comparing them to water. The rock is more, it'll sink. A plastic boat, or they use styrofoam even in kayaks and things like that on the inside, and it will float. So let's see some math. So we have a ring, and we can easily put the ring on a scale and get its mass of 8.99 grams. And the volume, we'd probably use water displacement. It's actually not all that much. It's only 0.796 milliliters. It's not that big of a ring. So is the ring gold? Let's use our density formula. Density is mass over volume. So all we have to do is substitute. So we have our 8.99 grams over 0.796 milliliters. Everything's in the proper units. And it's 11.3 grams per milliliter. Well, gold is quite dense. Gold is 19.3 grams per milliliter. So no, this isn't pure gold. And believe it or not, that might be okay, because we don't make jewelry out of pure gold. It's usually alloyed with brass. The reason for that is gold is a very soft metal. It's kind of brittle. If you had a gold wedding ring, odds are it would crack or break very quickly, because in everyday life, we bump up against things all the time with our hands, bump up against cabinets and desktops and, just as we're living our normal everyday life. Well, let's try another one. We know the mass of the substance. And I don't know what it is. Maybe it's some kind of rock or piece of metal. It doesn't tell us. And they put it into a graduated cylinder or something. So just like we know, when you put things in water, the volume changes. Here the volume went from 12.5 milliliters up to 31.8 milliliters. Well, density is mass over volume, but we have to figure out what the volume is. We have to take the difference. So the volume is 31.8 milliliters minus 12.5 milliliters, which is 19.3. Then it's pretty easy. We can just put it into the mass over volume formula 47.5 grams over 19.3 milliliters. And we get our density of 2.46 grams per milliliter. Aluminum's about 2.7, so this rock may have some aluminum in it. Maybe it's an aluminum alloy or aluminum ore or something. You wouldn't have to know that right now. Now here's a nice example, and sometimes they even do this in some labs. They have a piece of what's called rebar. It's reinforcement bar. It's used in concrete. And they cut off a little piece, and it's 69.658 grams. And notice what they did. They measured an initial volume at 13.4 milliliters. Or 5, excuse me. They tell us what it is. And then it goes up to 22.4 milliliters. So this is going to be really similar to what we just did. We know the mass. We'll subtract to get the volume. And it made the volume go up to by 8.9 milliliters. Then we can substitute into the density formula. Density is mass over volume. But I want you to notice something here. And I did this on purpose. Let's check significant figures. 22.4 milliliters minus 13.5. That's a subtraction. Remember, in a subtraction or an addition, you can only have the least number of decimal places. So this number only has 2 significant figures. The mass, they must have had a pretty good scale, has 1, 2, 3, 4, 5 significant figures. And all I did was write down what was in my calculator. And sometimes students will do this. They'll write every number down they get in their calculator. But that's too many. 5 divided by 2 means the least number of significant figures, or the number of significant figures I can keep, is only 2. And let's see, 2 doesn't round 8, so 7.8 grams per milliliter. Now, I think it's important also to see one where we solve for a different variable. So salt has a density of 2.16 grams per milliliter. We want the volume. I'm a big supporter of doing the algebra first whenever you can. So let's multiply both sides by V. Let's get the V out of the denominator. So density times volume is mass. Now we want volume. That's what we're after. Circle that if you like, or underline it. So volume is mass over density. And I actually have that in the typing. Let's see. Yep, volume is mass over density. I just didn't show all the algebra steps when I typed it out. The reason why this is good is because we only have to handle the numbers once. I think we can see that grams cancels. We're actually left with 1 over ml. So remember that you flip that. You multiply by the reciprocal. And we get a volume of 225 milliliters. Now there is out there, and you can certainly use this to help you check. But you still need to know how to do algebra. I mean, at this point in our academic careers, we need to start being able to do the algebra. But you can use this little triangle to help you. You say, well, how do I know how to set up? It's mass over volume, density. So we need to keep the mass over volume the same as in the formula. So if we wanted density, we could take our finger or our thumb and cover up the D. And we're left with mass over volume. If we want volume, you cover up whatever you're trying to get. So I'll scribble it out here. Volume is mass over density. Hey, and that's the formula we had. So you can use this as a way to, double check your math. When you get a test or a quiz paper, you might want to quick jot it down and just use it as a way to double check your algebra. Although, of course, I do encourage you to learn the algebra the right way as well.